Now let's learn how to use synthetic division. We're going to take this polynomial and divide it by this binomial. In synthetic division, you're going to take your polynomial and each coefficient we're going to list separately. Notice that it's in descending order, and also I don't have any missing terms. I have a negative 1x cubed, negative 6x squared, 9x, and 11 is my constant. If I had any terms missing, then I'd need a 0 for the coefficient. And then I'm going to take the 0 of x minus 2. So what causes x minus 2 to be 0? Well, it's 2. And another way to look at it, depending on your definition, is that it's x minus c. So whatever number this is, it's got to be x minus that number. So it's always going to be the opposite sign from what you already have. So I like to think about it as, well, what causes it to be 0? Positive 2. Now I'm going to bring the first coefficient down, negative 1. Multiply it by 2 is negative 2. Negative 6 minus 2 is negative 8. Multiply it by 2 is negative 16. Combine your like terms, or combine your terms, which is 9 minus 16 is negative 7. 2 times negative 7 is negative 14. 11 minus 14 is negative 3. And then whatever you have here in the furthest to the right is your remainder. This is your constant. And then we begin with our x to the first, x to the second, and we keep going if we add more terms. So the answer is negative 1x squared minus 8x minus 7, and then we've been asked to write the remainder over the divisor of x minus 2. So minus 3 over x minus 2 is your answer. And we'll use synthetic division in a lot of the processes on this page. Next we have what's called the remainder theorem. It says if I have a polynomial p of x, if it's divided by x minus c, then the remainder is p at c. So x minus whatever number this is, it's going to give me p at c. So I've shown you here p at negative 1. Typically we would substitute in negative 1. If I did that, I would get 11. So I did that beforehand just to show you that we're going to get the same number as if we just substituted in negative 1. This isn't necessarily a quicker way, it's just a theorem and a fact that this will always give you that number, that p at c. So if I want to find p at c using synthetic division, we're going to divide. So we're going to take this polynomial and its coefficients, 1x cubed, 3x squared. I don't have an x term, so I need a placeholder of 0. Constant is 9, and I'm going to divide by that negative 1. We're going to take whatever your c is, and that's going to be in our little box. So now, use synthetic division, bring down the 1, multiplies negative 1, combined terms is 2, times negative 1 is negative 2, negative 2, multiply is positive 2, and combined terms is 11. So notice that the remainder is p at c, and we got the same thing that we would have gotten if we just plugged in negative 1 into the function. And now we have what's called the factor theorem. The factor theorem, a polynomial p of x has a factor of x minus c if and only if p at c is 0. So if we divide and we end up with 0 as a remainder, we have found a factor, and that also means we've found a 0. So let's use the factor theorem to determine whether x plus 1 is a factor of this polynomial. Now if x plus 1 is a factor, that means that negative 1 would be a 0. So keep making that association. We need to see if this is true. Okay, so we're going to use negative 1 in our box. Let's So remember, we use the opposite sign of what's given to us in that divisor. So x plus 1, if we want to see if it's a factor, we use its 0, negative 1. Go for your coefficients, negative 1, negative 4, I don't have an x term, and 3. So bring down the negative 1. Negative 1 times negative 1 is positive 1. Combine terms, negative 3. Negative 1 times negative 3 is positive 3. Combine, you get 3. Negative 1 times 3 is negative 3. And then I get 0 as the remainder. So getting 0 as the remainder means that x plus 1 is a factor. And it also means that negative 1 is a 0. Now let's determine whether the given number is a 0 of the polynomial. So if I want to know if 4 is a 0, I'm also asking if x minus 4 is a factor. So to do that, if we're given the number 4, we're going to use 4. So remember that that's coming from x minus 4 being a factor. Negative 3, 13, 10, negative 56. And if we get 0 as a remainder, we can say that 4 is a 0 and x minus 4 is a factor. So we're going to bring down the negative 3, multiply, get negative 12, add or combine, and I get 1. 1 times 4 is 4. Add, I get 14. 4 times 14 is a positive 56. So my remainder is 0, which means that 4 is a 0. It also means that x minus 4 is a factor.